Today we'll see, introduction to DevOps, and from tomorrow we'll start our classes. Starting with our tools, whatever we discussed. But yeah, let's see what is DevOps first. Why we need to use it. Because why we need DevOps first thing. So what happens if there is no DevOps? What people what people used to use, before DevOps. So all these things we'll see today. Okay. Hmm. So let's start. What is DevOps? I think by name you'll know a little bit. So DevOps is like a combination of development and operations. Yeah, I think even by the definition, whatever you're seeing here. But what does it mean? So what does it mean is like integration between development teams and IT operations. What they do exactly, and how they work together to achieve something. So that is DevOps actually. So let's say without DevOps, let's take an example. Maybe a small example. We have a restaurant, let's say. So there is a chef, right? Chef. He'll do his thing. He'll prepare some dish, and there will be a waiter. You know, he'll deliver whatever chef prepared to customers. So there is a chef, there is a waiter, and customer. So their roles are clear now, right? So chef will do prepare the food, waiter will deliver it, and customer will have it, and he'll give the feedback. That's what generally happens in restaurant, right? That's what we do. So imagine, let's say here, chef does not know about waiter. He knows about waiter, but he does not know what waiter up to, or the chef does not know what orders waiter is getting. That is one thing. Another thing, from the waiter point of view, the waiter does not know about chef at all. He don't know what chef is doing. He don't know what he is cooking exactly. He don't know when it will cook, when it will be ready to give to the customers. So he's in between. Or even one more example, maybe chef keep on changing, making some last minute changes. He told some chicken biryani, let's say, before sending, the chef adding some more salt or something, some onions or something like that. So it's getting delayed. So but waiter is waiting, to get the order from chef, and giving to customer. So there is a delay is happening here because lack of communication. One thing, lack of communication is the main thing here. What if, let's say, the restaurant has a standard process, so everyone should follow this? And what if, let's say, the chef and the waiter are communicating regularly? Chef knows what waiter is doing, waiter knows what chef is doing. So, and now, before adding extra minutes, everything and all, what if there is someone to check before sending it to customer? Let's say we'll do like taste check, right? Once we finalize the dish, we'll do the taste checking, right? Okay, this is good, you can send it to customer, something like that. So here what's happening in second situation which I told, since they are communicating together, since there is a test also, there is a set of process which they are following, they speed up the things. Similar way, DevOps also does to what to IT, to IT industry, or to organizations. See, what is doing is exactly, I mean, to talk about DevOps, it's clearing the gap between developers and operations. Just a simple point of view. Just, it's clearing the gap between developers and operations guys. So that w- with that what happens? That's the main thing. So with that what happens is you it won't help, DevOps not just for helping individual, it's helping the organizations. That's why what we say, so we told it will, it cleared the gap between developers and operations, but what it does, it will speed up everything now. That's what happens. See, you are a developer, I am, a DevOps guy, operations guy, let's say. I know what you're doing because we both are in sync now. So you are developer. You told, hey, tomorrow my task will be finished. There will be some small changes, some small testings. We are ready to release by Wednesday, day before, you know, day after. Sorry, day after tomorrow. So now you told me I know the information. Now I'll prepare by myself. Okay, Wednesday there is he'll be, ready with his code and everything. I will prepare what else needed from my side. So I have 2 days time now, right? I mean Monday and Tuesday. So by this communication, there is no lag. There is no lag actually. But let's say imagine there is no communication. You are a developer. I'm a operations guy. Suddenly you came on Wednesday. He told, I am my part is done in the next 1 hour. So what I can do? Of course, I have to do my work. Which may take 1 day or more than 1 day. Then you have to wait. Correct? This gap was there earlier. Let's say we decided Wednesday, right? Suddenly developer came in the last just 1 hour before and told, hey, I need more time. It's extend again. So and again ops guy needs to wait. So what I'm trying to say is DevOps cleared the gap between developers and operations. It makes sure that these both are, it can be two persons, two teams, anything. So these both are in sync to achieve better results. What are those results? It can be faster deployment cycles. It can be faster bug findings, bugs findings. I mean, if there is any issue, after you deploy the code, you got some issue. We told, right, Apache, let's say as an example. We have just an example. Let's take Apache. We deployed our code to Apache to production. I mean, we made it live, but suddenly there was an issue. We can able to find out easily because we are monitoring it. So DevOps handles all these things. So there are a few concepts in DevOps to achieve these things. I told how we clear the gap. I mean, we clear the gap between dev and ops, dev team and ops teams. Let's say, how to do that. I told like faster delivery or faster deployment cycles. How to do that. I told like how to find the bugs faster. How to do that. So there are specific set of concepts which DevOps uses to do all these things. Those are called continuous delivery and continuous deployment, continuous monitoring. So there are these things which we does. We'll see all those also, don't worry. But this is what DevOps is about. So if someone asks what is DevOps, don't by heart and just say the definition whatever you find on Google. Everyone knows that. What they're trying to ask you is what does it mean by the definition? See here it says DevOps is software development approach that emphasizes collaboration, communication, and automation between software developments and IT operation teams. It aims to streamline the software development lifecycle, leading to faster release cycles and improved quality and increased efficiency. He knows this. Everyone knows this, or they may need to know. But what does this means? That's what I just explained. So don't go for single line answers. Never go for single line answers. People need explanations, at least here, not everywhere. So people need explanations. Got it right? But yeah, let's come back to our topic. So what? Okay, we were discussing DevOps is like bridge, a gap, a bridge between developers and operations, which does some things. But what people used to do before DevOps? That's the thing mainly. Of the topic, I'll say one thing. Always use that model to do something. There is a model called STAR. I used to tell in every class. There is this no STAR. Yeah. So this, since we are we haven't started the technical yet. Use this method, STAR method, for anything. Let's say you want a bike. Maybe this is not a good explanation. Let's open another image. Yeah, maybe this one. It's not DevOps. I'm just trying to give you something. So let's say, as just taken any example, you want a bike. Of course, your father asked you why you need a bike. You need to have answers, right? So idealize any situation in this approach. Answer anything in this approach. Star format. So obviously, by now, situation, task, action, and the result. Situation. What situation you are in to buy a bike? Maybe I'm going to college every day, by walking 10 kilometers, or rainy season. Sometimes in mud, there'll be too much mud, right? I mean, obviously. So it is too much, or in summer season it is too hot to go, or bus is not coming on time. Maybe I'm missing some classes. Something. The situation which led to this issue, which led to this idea to buy a bike. And task, what I have to do to come out of the situation, buying a bike. What action I need to take for that to do the task. If you are ask your parents or buy by yourself, whatever it is, I mean, just saying, let's ask your parents. So what is the result of that? So now I'll be on time for the college, I'll be on time for the class. Even if it is rain, I don't need to stop. Even if it is too much hot, I don't need to stop. I can just put on my helmet and leave. Take this example for anything, you'll get answers easily. I mean, you'll figure out the things easily. See, anything, just take anything, randomly. Explain the situation where you are in currently right now, first thing, and go after that. So it will be easy for you. Take anything, let's say, I mean, bike is one of the example. I mean, you can take any example. Just use this approach. It will be easy, for you or for others also to understand what you're talking about. So let's say you want to give a demo in your office or something. You want to give some seminar or something. Without star, it will jumble. I mean, it will be a little scrambled. But if you use this thing, because situation comes first, why the hell I'm in this place, the first thing. So it will be easy for you. So yeah, sorry. Why I told star is, it's not part of DevOps, as you know it. I'm just trying to say something, meaningful at least. Might be useful. I use this approach every time, so try to use it. It'll be easier. I mean, it'll be good. I mean, so now let's use this star for our DevOps. Why DevOps? I told my team member, or sorry, my manager, hey, let's use DevOps in our team or in our project. Let's say. He told why. Why the hell I need to use DevOps? So first, address the current situation. So tell him. I'll tell him, like, hey, currently, we have development team. We have operations teams are there who does everything. So what happening currently is there is no communication between us. So developers writing their code, whatever they are doing, and we are, after the testing is happening, if the test fails, it will come forward for the next steps. Next steps are like maybe deploying it once the testing is done. If the test fail, it will go back to developer again. So this process is all manual. Until the test is passed, no one deploys the code, which is the rule, software rule by default. So these things are happening manually. That's one thing. And another thing, we have no communication, as I mentioned, right? There is no communication. So we have no idea when that will be faced. So of course, when we ask, they'll send a mail or something, but so there is no official confirmation when has to be done. There is no plan, release plan, something like that, so that everyone knows what's happening and when it will gonna happen, the next time or something like that. So this is the current situation, and we are releasing. Maybe releasing means deploying. The new features they'll release. It means deploy. So maybe once every 3 months we are releasing our new features, which is we are way behind the market. In the market, everyone is releasing once per week or twice per week, but we are not like that. We are releasing way way older than market currently. Due to this, we are out of maybe a competition or something, whatever it is, out of the race or something. Why this happening? Lack of communication, lack of automation, all these things, lack of process which we need to follow, lack of the rules which we need to follow. So this is the current situation which we are following. I told my manager. Now manager asked, okay, I got these points. What we have to do for to overcome all these things? Task. Let's implement DevOps. Okay. So DevOps, I'm telling you again, DevOps is not just some random thing. It's set of tools, set of process which we follow. We together call it DevOps. So DevOps is not an like a specific. Let's say if you take Java, we know it's a programming language, or Python or something, or take anything as an example. Any testing, any tools, any Power BI or something. They're all tools. The name itself by the tool name, but DevOps is not like that, because DevOps is not a tool. It's a set of process or set of things which we follow to achieve something. Of course, what are the set of is, it will be policies, it will be rules, it will be multiple tools together called DevOps. So don't think DevOps as one tool or something like that. Got it? So now coming to our task. Okay, we want to implement DevOps. Okay, I got it. And in within DevOps, we chosen what are the tools required for us, and what is a procedure, the approach which we need to take. Got it. Action. Action part. What is in here in the DevOps action part means sorry, implementation part. We got the task to implement DevOps. Implement it. Set up everything, whatever required. And finally, what is the result? As we discussed until now, you know whatever the gaps were there, they are filled. Whatever the things we used to achieve slowly, I mean maybe it takes used to take more time, now it's faster because of the DevOps. As I told you, why? If they have communication, they can work parallelly, because they know everything what's happening, when it's going to happen. That's the thing. That's uh, about DevOps, and that's about the star methodology, was it? I told. But yeah, that's okay. Now, still it's not finished yet. So as of now, we discussed what is DevOps. We told like a set of principles or something to clear a gap between developers and operations. Blah blah blah. See, when someone asks you what is DevOps question in an interview, if you're a fresher, it's okay, because they want to know you. You know what you capable of. Imagine you kept 5 years of experience. You have 5 years of experience. Sorry, and If someone asks you what is DevOps in that interview, maybe at one point of maybe in the middle of interview, you know what does that mean? What does that mean is you're not performing well. Usually people ask tough things at the beginning. Sometimes, most of the times. I mean, not everyone. They'll ask tough. They'll start with tough, and they'll go easy down. Sometimes they'll start with easy and they'll go to the tough. But in between, you hear this question. It means most of the times I've seen, heard. I mean, I've seen. When I was also doing interviews, it means you're not performing well in that interview. Because imagine for a 10 years experience guy or 15 years experience guy, you ask a basic question, they don't know. They might have forgotten it because they're so deep into the technical things, they'll forget what is DevOps. That is one case. Or you're not saying anything properly. You're not performing well in the interviews. In that interview, I meant to say. So he'll come to basics, so that at least whether he knows the basics or not, he'll try to test it. Test you. That's what happens. Okay? But don't think wrong, it's just a question. I mean, just you can just answer it if you know it. That's fine. Again, out of topic. I'm just saying. So yeah, I told what is DevOps. I told some process, which we follow, some rules, some set of process which we follow. What are those processes? Those are the main things. Those includes DevOps. So I told DevOps definition so far. If I haven't told those process, whatever set of rules which we follow, it's not DevOps. Then I just told you the definition, not what we follow inside, not what we do inside the DevOps. So the first thing is SDLC. It's not a part of DevOps, but we use it. We use it means we take this approach uh, for DevOps. So SDLC, it means, I think software development life cycle. It's like starting from planning until deployment, what to do, how to do. So let's say you got an idea. Maybe you got like I have this idea. Any example, let's say to make an application, to develop an application like Facebook, as an example, or I don't know, Google or something. Where do you start? First thing, what you do? Starting from, you'll plan, right? How, where I need to start, from where I need to start, and where I need to start development or so, whatever it is. So first, I'll plan all those things. Next, I'll gather the requirements. Requirements, what are required to develop this Facebook like application or something. Next, I'll design it. Okay, this should look like this. This should look like this. My application, if I log in, left side some options will be there. In the middle there will be home feed. In the right side there's one more options. On top, home option will be there. On the right, on the right side, let's say here like this. On right side, my username. If I click on that, so few options should come. Log out. These are all designing part. So design, I'll do design. Next, once the design is done, I'll do development. Once the development is done, what I have to do? I have to do testing, whether it works or not. We directly don't deploy it, right? We have to test it before. Otherwise, there is no point here. Without testing, how can you know whether your code is working or not? So testing is the most important thing. And finally, when the testing is done, we'll deploy application. So let's say Apache for now. Just deploy. Don't say to Apache always. Deploy means deploy to servers, production, or so there will be some environment names. So we'll come there, don't worry. But yeah, so just say it deployment. And finally, once deploying is done, monitor it. Where we'll be monitoring it, whether it's working fine or not. If any issues, we'll fix it or no. We'll fix it. We'll provide support, customer support like that, or general support. So we'll do all these things. This is called software development life cycle. It just defines what we do starting from planning to deployment. Maybe this one. Just starting from planning, analysis. Okay, planning, analysis, both are fine. Designing, implementation, testing and integration, maintenance. Let's take one more image just to clear This one may be fine. Yeah. This one. Starting from, see, brainstorming and setting goals. See, different names, all same shit. So don't worry. So setting goals, planning. They are talking about team here, but yeah, it's fine. Analysis and plan requirements, analysis, designing and architecture. Finally, coding and implementation means development. Whatever, write something like that. Testing and QA, both are same. Deployment and maintenance and feedback. Maintenance feedback means monitoring it if any feedback comes from the clients, so how your application is, blah blah, like that. And you'll be monitoring by yourself as well. Got it? So the software development lifecycle works. What we do here? No, we don't do anything here. It's all, there is no DevOps here, but we will be involved from here, from fifth step. So you will learn. I mean, what we do? Do we do testing? Yes, we do testing. We, of course, deployment is part of our job. Monitoring and feedback also is part of our job. So here, what's happening is they divided these things, not divided. So we divided by ourselves here, which is developer part, which is DevOps part. So we'll see that. So this design until coding, we cannot do anything. It's developer task. Architecture will be there, business heads and all. They'll do it. We don't care about it. Once the code is ready, what we do? Once the code is ready, what we do? That's what our task is. That's where we comes. See what happens is, now let's say developer is there. They wrote the code. I mean, team is there, so they wrote the code and they're ready. Now we need to deploy it. What does that mean? We need to deploy it means they should have tested already. Not might have, should have. They should have tested already. So once the testing is done, then we are ready for the deployment. But you told we need to test, right? Yes, of course we need to test with the help of the tools. We don't write the test cases or something. With the help of few DevOps tools, we test the code according to developers' idea, according to developers' plan, how to test, what kind of, because there are lots of testing types. We don't care about all those. We just they'll test it, but we'll show them the platform on where to test. That's the thing. So I told you what they divided something like that, right? So coding is not our part. After coding, they'll test it. Okay, once the test is passed, they'll build it. Building means building the code. Let's say, forget about what does building do and all, but we'll see later. But a building. So here, if the build fails, maybe something is wrong with the code, obviously. So it'll go back to developer. Again, developer fix something. He fixed some code. Maybe some code was wrong. He wrote something. Not our issue. So again, they'll test it because he changed the code, right? They have to test it. The new one also. So he'll test it. Again, it will come to build. Now build got success. All happy. Similar way, once the code is done, tester has to test it. It failed. In testing, it failed for some reason. It will go back to developer. Hey, testing failed for this. Check this. So this continuous process will happen until the build is success and ready to be deployed. This process is called CI process, continuous integration process. CI, continuous integration. This repeating cycle. I mean, not writing the code. Writing the code is manual by developers. After writing the code, whatever happens, testing and building, what I told, right? Forget about what they do, what kind of testing they do, what the building means. But for now, make sure that all they are doing is application. They are just making sure application is ready. That's it. That's the only thing. Got it? So this continuous process until the build is success. What I told, right? Until the test is success, build is success, they'll do it repeatedly and manually, the CA process. But DevOps introduced a few tools to overcome these manual steps. Now, as a DevOps guy, I came in here. I told, hey, this continuous integration process. You're doing it manually. Let's automate it. I'll bring some tools. Blah blah blah. I'll bring some tools. So he bought some tools, and he implemented this. So now, whenever developer push the code now, since we have automated right with the help of DevOps, when developer push the code, automatically it will test it. It will build it automatically. If it is success, I mean, if it is success, it will success. The build is success. If it is failure, it will show it immediately because it's running automatically. There is no manual intervention now. So what's happening? He is looking. Okay, I know. My change is tested. My change is built. Okay, build failed. Developers can see the error by themselves. They don't need to notify by anyone. Okay, testing, maybe here it's failed. Let me read it again. Let me push again. Let me change this code again. Again, once he made his changes, developer made his changes, it will start again. It will automate again. So it will take the latest code, test it, all good. Next step, build it. It failed again. Again, developer will write something. So this loop continues until sorry, the build is ready, until the package is ready to be deployed. So the package is ready to be deployed. We, why we call it package or build is there are some tools which follow this. To keep it simple, I told you, right, tar file, let's say, or zip file. It's one file. Within that, there will be multiple files compressed. Similar way, package or build all comes under the same zip community. Like, they are all one files which we deploy. Inside it, there will be code. For sometimes we'll deploy all the code directly. So we don't care about the code. Depends on whatever they are using, we deploy it. That's it. So don't worry about that. So yeah, coming here, CA, continuous integration. So here what's happening is we automated it now. So it is fine. It is fine. See, DevOps helped here to fasten the process. That's what it did. It did, I mean, sorry, not did. That's called CI, continuous integration. Let's open here. Integration. Maybe let's see the definition. It's a software development practice where developers frequently integrate the code changes which we discuss, like into shared repository something. Forget about it. We'll discuss tomorrow. Triggering automated builds and tests to detect resolve issues easily. See, that's what we discussed so far, right? As I told you, don't look for a definition, look for an answer, look for a description. So it will be easy to explain for anyone. Got it? So this process is called CI. Maybe let's show an image also, it will be useful. Yeah, this one. See, developer source control is where they store the code. So don't worry. Developer is writing the code and it's building, testing, report, all good or not. If it is all good, deploy. Release, I mean deploy. Deploy it won't be handled by CA. We will see that. So for now, this is CA. Coming to next thing, we have CD. CD. Continuous delivery, one thing. Continuous delivery is like, hey, what happens after the code is ready? See, I told CA. CA means it's making sure the code is ready or the package is ready to be deployed. Delivery comes after CA, continuous integration. Continuous delivery comes after continuous integration to deploy the code. To deploy the code. What happens, in the delivery? In the delivery, it will deploy the code. It will deploy the code. Simple. Whatever CI did, it will take it. This will do it. This will do the deployment. That's what our next step in SDLC lifecycle. Correct? So until testing and QA, CI covered it. Of course, not all the four, fifth part. So see, continuous integration covered it, and the code is ready now. Now what should do? We need to deploy it. So CD will take care of it. CD means continuous delivery will take care of it. But at but here two things here. Up to what length it will deploy. So, so there are we don't directly deploy to production. We'll have multiple environments. Multiple environments. So what happens is like, you know, sorry. What happens is like we'll have different environments. Why? Because we'll test in all those environments. We'll make sure before deploying to production. Production is the ultimate. I mean the last thing. So we'll make sure that it is working fine. That's why we'll test in different environments. We'll test multiple times. We'll test multiple ways also. So continuous delivery here comes is deploying to lower environments automatically. See, usually what happens is the environment names will be like this: dev, QA, UAT, production. Common names. Of course, the names may change a little. Production will be same. It won't change. The remaining lower environment, some people call it playground, some people call test, but all are same. Don't worry. Production is production everywhere. They won't change it. No one changes it. So they have multiple environments. Like if you want to go to first floor, you'll take step one, right? Directly you can't just step on the last one, right? So we'll go step by step, step one, two, three, four, until the first floor last step to reach that. Similar way here, DevOps also, if you want to go to the top, the production environment, which is the last one, main one, you'll go step by step. You'll test in lower environments. One more testing will happen in another environment. In other environment, there will be different kinds of testings happens. We'll test each and every step to make sure there are no errors after deploying the application into production. That's what generally happens. So continuous delivery is one part of it because it will deploy. It will comes after CI, because CI made the code ready. CD delivery will take the code and deploy it to lower environments, whichever the lower environments they are using. Dev, let's say Dev or QA or UAT, something like that. So that's what delivery do. Just it will deploy. It will deploy the application to keep it simple. But there is one more thing called deployment also. Not only continuous. See, you might have seen if I do this, these things comes. I think you'll know this by now, maybe by this image. Deployment also is there, which will deploy the application. But the only change, see here, it may be little misleading, but generally this was does. See, code done, unit test, integrate, acceptance does. Until here, this is CI, sorry, continuous integration. Deploy part, delivery and deployment. They are just saying delivery is manual, deployment is auto, but no. So delivery we don't say deploy to production, we will say deploy to lower environments. Deployment, continuous deployment, we say deploy to production without manual intervention. Without manual intervention. Same thing. Delivery and deployment both are same, except delivery, you know, deploys the application into lower environments. Continuous deployment will deploy to production without manual intervention. That's what CA and CD. You may hear lots of things like this because DevOps built. Uh, I would say maybe DevOps built on the CA/CD thing. So that's what we covered in sixth step of a software development lifecycle. See, we even though we don't follow this, we don't care about this, but we are part of this with the help of DevOps. See, all we are doing, all why the DevOps, why the hell we need all this follow CI/CD and all is to help the organization or the project to have their application ready in the production for the clients, for the end users. That's what we are achieving here. That's what we are doing, not personal goals, obviously. So of course, developers don't understand that because they are not professionals. So, but we are. So, still we are in software development lifecycle only. Our process CI CD also covered here. CI CD covered here. There is something called maintenance and feedback. Of course, we call it like a monitoring and maintenance, or maintenance or monitoring also. Just you can call it monitoring or maintenance. Anything is fine. This part comes continuous monitoring. Mind my please don't mind my spelling. Sorry. Continuous monitoring. See, same thing. Monitoring means obviously you need to monitor the application, you need to monitor the environment, the infrastructure. I mean servers, everything. And if any issue, you'll figure it out. You need to fix it out. That's what it does. Continuous monitoring. Got it? So CI, CD, and CM. CM nowadays they call it, but yeah, it's okay. Just ignore. I mean, just call it monitoring. That's it. No need to call continuous monitoring. We don't continuously monitor it until we get an alert. See why we look at monitoring thing. Once we get an alert, hey, something is done, then only we'll check. We don't continuously monitor. That's no wrong term, but yeah, just we'll just say monitor or maintenance it. It's fine. So that's about uh, CI, continuous integration, CD, delivery and deployment both, and monitoring. As I told you, but there is no DevOps term involved here. That's what I told earlier, right? DevOps is not a tool or something. It's set of process which we follow in that. That what makes it DevOps. I think by name you know it. It's not a tool name. It's a mix of development and operations. Because of we follow all this process. So continuous integration we follow within DevOps. Continuous within DevOps, not development. I'm saying again, continuous integration, delivery, deployment, monitoring. We do all these things. That's why we became DevOps. DevOps again comes under this bigger thing called software development lifecycle because we are part of it. Why we implement DevOps? For the application only, for the project only. That's why we are part of that. That's why we're part of that. Got it? And what else in DevOps? Maybe I think nowadays we see it DevSecOps. I think someone asked the doubt last time. What is DevSecOps? Now you might know the answer easily. Integrating security into DevOps called DevSecOps. What does it mean integrating security? Okay, code is ready here. CA part is done. Continuous integration part is done. The code is ready. The package is ready to deploy. But we don't deploy that directly. Before deploying, we'll do security analysis on top of that. What does it mean? Analysis is are there any vulnerabilities or not? Because what happens, sometimes we see red companies will get hacked. They have to pay some money, ransom, to get back or something. Why? Because if they have the code, whatever they developed, whatever the infrastructure they are vulnerable to the internet. See, imagine I have a database with my sensitive data, or I have a phone. Let's say my phone is there without a password. If anyone can steal it, if they, anyone can, touch my phone, they can access it directly. What is the security over there? There is no security, right? He can go to my photos or my WhatsApp chat, whatever it is. But what if you set a password? It will be difficult for them. What if you set, face ID or something? It will be more difficult to them. What if you enabled some option to to reset everything, something, or lock or call some or something like that, some precautions. So these things are security measures we take so that our device won't get lost. Our device, even though it got lost, they don't get anything out of that. So these are called security measures. Same in the DevOps also, DevSecOps. We implement these few more things, at a security level, you know, to make sure our application won't get hacked, they are safe, they are not accessing our sensitive data, blah blah and everything. That's called DevSecOps. It's not a different job title or something. They're all DevOps. Someone someone will say, hey, I got opening for DevSecOps. Don't think as like something else. Don't get scared. I just what I want to say. They are all DevOps, nothing. Security tools, we just use few things which we don't care really, because there will be a security team separately. Because security is the most important thing in every IT organization. In every, take anything. See why the hell they need login, access cards and everything. Why the maybe or thumbprints? Some people, some companies may use it. Why the hell they need to give their own laptops, even though if you have personal ones. Start with these basic things. You'll understand security is the priority thing for IT. Any company. See, you kept a company, you put a company, let's say, you'll ask users to log in with your laptop just because you want to save some money. What if user gave everything for more money? Gone. All your sensitive data is gone, information is gone. So security is the main thing for any company. So DevSecOps, we don't do anything for company level, security things. It's separating. For DevOps things, for application level, we control few things. We'll see one of the tool which I basically covers these things in our topic, but yeah, not fully. So these are all regular day, precautions which we take. Regular day precautions, which will prevent all these security things. So DevOps, DevSecOps, all are same. So don't worry about all those things. Some people will call, hey, SRE, you might have heard SRE, Site Reliability Engineering. Again, they think they are different. They are not. No, they are not. They are not different. Site Reliability Engineering. DevOps implements all the things. All the things. Site reliability, SRE, to keep it simple, SRE, SRE. They keep more focus on observability. They keep more focus on observability. So what they do is generally is they may not build the pipelines, they may not build pipelines or deploy something, but they make sure the infrastructure, whatever the application is there, whatever we have running, they make sure they get the most details about it. Most details about it means whether it is running or not, at what level it's running, any issues, any troubleshooting they need to do. All these things SRE will take care. Site reliability engineering. If it is SRE, don't think as it's different than DevOps. No, everyone thinks that it's different than DevOps. Even see, I'm an SRE. My role is SRE. That but that does not mean I don't work on things. Just different names they'll give. See, just because you change your name does not mean you're not a changed person, right? You just change your name. That's it. That is the only thing you did. Similarly here, of course, no one agrees. Most of the people agree with that. Some guys won't agree, obviously, but it's fine. Everything is same. If you got a call saying SRA, hey, no, I'm not SRA, I'm DevOps. No, don't say like that. Agreed. That's what. Everything is same. Maybe if you go to a bigger organization like Microsoft or something, they might have a different teams. SRA team, they'll be a different team. DevOps team, they'll be different because they have money, they have budget. But if you go to any mid-range companies, SRE, DevOps, both are all same. Why? Because, of course, what they do generally is, as I told you, right, SRE is like more focus on observability. Observability means monitoring and everything. Monitoring, every infra, every server and application and everything. They'll keep, working on that. DevOps on the other side, working on CI/CD pipelines, deployments, and all the operations, mostly automation side. But in all the organizations, most of the organizations at least, DevOps will handle SRE things. SRE also will handle DevOps things. Both are same. I am handling both. Unless you're working in a Wipro, Apple, or some big huge companies, and until they lay off, so you'll be working in a different teams. Maybe I don't know. I don't know, if they work or not. But yeah, so that's what DevOps is. SRE, sorry. So DevSecOps, DevOps, SRE. What else? What else is there? I think that's it. Yeah. Senior DevOps consultant. Forget, I mean, those are our designations. So don't worry about all those things. If you got a call, ask for JD, job description. Decide based on that, not based on the role. See, if you go to small organization, they'll have architect, specialist kind of roles. Depends on organization it is. We cannot say anything. It depends on organization. Don't get scared about all those roles. Sometimes some people will have technical lead. It does not mean you lead the team. It's just the tag they have. So don't worry about all those. Check the job description. Whatever the tools you learned, what in DevOps or in cloud, something or Linux, if it is there, if it is matching, yeah, go for it. If it is not, no. Check the job description, not the role title. Correct? Yeah, but that's fine. Forget about this thing. So coming back here, I think we have covered here, right? Software development life cycle, what we do, where we are at. CI, CD, D means delivery and deployment both, and CM, don't call it. Yeah, you can call it CM. It's fine. Yeah. Anyway, so continuous monitoring, maintenance, both are same. M for maintenance, monitoring both. Yeah, so you can able to call it. So once this is done, again the cycle starts. Again the cycle starts. So that's about all about DevOps. All about DevOps, I don't say about DevOps. Everyone will have different approaches for this, but the end result is same. If you take a video, he might say it differently. If you take another video, that guy might say it differently. But the end goal is same. All about DevOps is same. What everyone is trying to achieve with DevOps is same. That's what I'm trying to say. That's all. So before closing, there is one more small topic to discuss in this software development life cycle only, not outside of this. So this is one of the models. I mean, software development life. This is how the development cycle looks like. So there are models in this one. If you take any car, let's say BMW, let's say as an example, everyone knows it. There will be models, right? X1, X2, X3, X4, something like that. Why? Because different features, different models, obviously. X1 may don't have something, X2 will have that, X3 will have more, something like that. Some features are different. Similar way, SDLC also we have few models. One is waterfall model. Let me write. Sorry, waterfall model. What the hell? I cannot increase. Oh yeah, waterfall model, agile model. You might have heard this agile, recently. Not recently, maybe if you start, you might have seen this agile methodology. Agile methodology, waterfall. I think it's long gone, but yeah, agile methodology, something like that. But we'll see what are those also. Waterfall means what happens, Sorry, where is this? Yeah, what happens, all these things are there, right? Coding, testing, and QA. They'll come one after the other. So now I got an application idea I want to develop. So for the first 6 months, I develop the whole application. And next 2 months, I'll do the testing completely. No development, only testing. After testing is done, of course, in between testing fails, it'll go back to developer, they'll do again, blah blah blah. All these things happens until the testing is success. Next thing is deployment. Maybe it'll take 1 month to deploy. Why 1 month to deploy? Just one day, right? Of course, but you need to. This first time you deploy, you need to prepare environment, everything. Imagine here, in this waterfall approach, what I told, first 6 months you're writing the code. It means the QA guys, testing guys, they are sitting idle. The operation guys who needs to deploy, build, and everything, they are sitting idle. See, there is a waiting time here. Correct. Again, once the 6 months development is done, testing is completely going on 2 months. Still, the operation guy is waiting to deploy, and developer is also waiting to finish the test. Finally, after 2 months, after 7 months, it came to operations guy to deploy. Again, some issues over there while deploying, maybe something else, some dependency or something. Again, the cycle repeats. This is a too much waiting process, too much headache process. See, imagine now this whatever the project we are discussing takes 1 year to release because of this cycle, waterfall cycle, what we are following. This is a linear approach. What we say, linear means one after the other, one step after the other, one step after the other. Correct? See, we have two legs, right? We'll be walking with those two, not with one. Imagine how much time it will take if you just walk with one. More time, obviously. But what if you walk parallelly with two legs? Of course, you're walking with two legs, which is parallel. But of course, it's one step after other, which is fine. But not one step at a time. No, not with one foot. I meant to say, sorry. One step at a time is fine, not one foot at a time. So this waterfall method, when developers used to follow the waterfall method, takes too much time. Takes too much time to release any application because, as I told you, one after the other. Development 6 months means after 6 months only they'll start testing. After the full application is ready, they'll start testing. I just told 2 months for testing. It may take 5 months, 6 months again. See, 1 year over here. Again, deployment. So, lots of waiting time here. You know what they did? They bought something in called Agile. Bought something called Agile. So, this Agile, they started working in smaller cycles. So, now we discussing here development, it will take 6 months. Okay, why to 6 months now? Let's do one thing. Let's divide this application into smaller parts and take one part each time. So now what happens? Let's say my application Amazon. Let's take Amazon. So to develop the whole Amazon application, earlier it used to take 1 year, and testing 5 months, deployment maybe 1 month. Let's say, got it? So this is called waterfall method because we are writing the whole code for the application. But now Agile came, hey, don't deploy like this. Divide the application into smaller parts. You know, what are the main components in the application? A login page, items, whatever you're saying in the right, and cart, add to cart, finally payment. These four, right? I mean, I'm just saying, not really these things, but I'm just saying. So let's start with the login page. First, we develop login page. So we'll set a cycle. Maybe 1 month we'll develop the login page. Within 1 month we deploy it also, because now it's a smaller thing. It became smaller now because we out of the application we took one feature. And we deploy it. Deploy it means the development happens, testing happens, and deploy happens. Maybe within a month. Within a month we have at least somewhat ready. Login page is ready. Of course, once we log in there is nothing, but at least it's ready. As a prototype is ready, at least we can show it to clients. Okay, hey, this is what we're doing. Earlier clients used to wait until 1 year, which is not a good practice. Now Agile came, see, it's divided into smaller parts and we are deploying it. Next, login page is ready. Next month, payment gateway. Payment gateway means the payment page, whatever credit card or whatever, we'll see those things. Work on payment thing, maybe 2 months. Okay, work on this thing. Within these 2 months, we have DevOps now, right? They are developing it. Meanwhile, parallelly, with the help of CI and CD tools, automation, we are testing it and deploying it in lower environments. Once they are ready, we'll deploy it. So this is also ready now. Next, cart page maybe. So like that, they divided the application into smaller parts to make the development cycle smaller. To make the development cycle smaller. As I told you now, earlier waterfall approach 1 year now. Now it still takes 1 year to write the code, but smaller parts, smaller cycles. Earlier, what they should 1 year they write the code, everything, login, cart, everything at one time they'll release. But now they're releasing one feature at a time. This became easier right now. By this Agile, we know what's happening. Where are we at? What feature are we currently working on? What thing we are going on? This have transparency, right? Than waterfall. That's why people go for this. That's why Agile comes in place. Agile methodology, sprints, sprint planning. I think you might have heard about this. But yeah, I'll show you at last, how it looks like and everything, because yeah, that we'll see. Don't worry. That's why Agile came. Agile divide them into smaller parts, divide application into smaller parts, and we work on small cycles. Got it? That's how it works. That's how we do. That's why nowadays I think no one uses waterfall nowadays. Nobody. I'm telling you, right? Nobody uses it. Everyone uses Agile only. Agile methodology. So what we'll do, Agile means today we discussed it. We will have a meeting. Okay, what is our Agile? What is this cycle period? As I told you, right? Small cycles, small time cycles. 1 month, 2 months, or sometimes 2 weeks. 1 week also we have cycles now, but it's fine. Yeah. So let's say we'll decide. Okay, cycle is one month for us. So within 1 month, what we can develop? Login page. Okay, and log out login button, OTP validation, something. As an example, I'm just saying, username login, something like that. Within 1 month, we can able to log in all these things, and we can release it within 1 month. So meanwhile, DevOps also prepare them, testing also prepare their whatever they want to test. So they'll do all these things. Got it? Got it, right? So that's what Agile does. So as I told you, dividing into smaller parts. They call it, yeah, I can say it, microservices. They're dividing application into smaller parts and they deploy it separately. They call it a microservices. Imagine, let's say, think this as an volumes, or disk, local disk C D E F, like that. We have a disk, and we are just using one partition, or if the one partition local disk C, let's say, if that is gone, the disk is gone, or let's say the local disk C has some issues, it's gone because it's just one partition. But imagine, as I told you example already, imagine, like, we have multiple partitions. If local disk C is gone, the OS may gone, but the data in local disk D, E, F is still there. Correct? Similar way here, in application terminology, they divide into smaller parts because you they are independent to each other, and even if they, let's say, uh, what do you call it? Even if they, let's say, one thing is down, the other thing won't be dependent on it. So they call it microservice architecture. That's how developer works. We don't care about it. We just deploy whatever it is. So now microservice architecture means they are running independently. Let's say you opened Amazon, you logged in, but the payment service, the payment microservice is down for some reason. It's not working. But still, you can log into Amazon. You can check the items. You can add to cart, right? Payment you can do it later. Correct? That's what you can do. But imagine, let's say, they are all not divided into microservices. They are a single application. Payment is down means the whole application is down. If local disk is only one partition is the local disk C, if it is gone, the whole data is gone. Like this. That's called microservice architecture. It became popular in the last 10 years, so everyone uses it now. Earlier, what they use, what the term they use as a single application as well. What is then what we call it? We call it a monolithic. Monolithic. Monolithic application. Single self-contained application where all its components are tightly integrated and deployed as a single unit. See, as a single application, we deploy it. Let's see microservices. Microservices, where is this? Because we divide them into smaller parts and we deploy it. Independent, as they'll act as independent service. Of course, they'll connect together. They'll talk to each other. See, payment gateway payment will talk to cart will talk to payment, but they're just running independently, so that one won't affect the other. If something goes wrong, one won't. If cart is down, you can still make the payment. You came to payment page, but cart is down, but still you can pay. You can pay the payment. But if it is a monolithic architecture, one thing is down, it means all the things are down because it's deploying as a single unit. That's why. That's why people uses agile methodology and microservices concept for application, development, deployment, and all. And we DevOps help in those deployments with our DevOps automation, our tools, and everything. Got it? So that's all I know about DevOps. Of course, where do we start it? How do we start? What our task is? What I told, after development, coding we don't do it obviously. After development, our work will start. So we will start from there. So I am developer. I pushed my code. What happens after that? We'll start from there. That's where all this tool comes. Where the hell did I store it? Somewhere. Yes, this is done. It's fine. These will start from this NV setup. It's nothing. I mean, it's fine. From here we'll start. We'll start from here. All these things we'll discuss. Got it? Of course, we have discussed these things already. It's fine. All these things will come after all. Each and every tool have a purpose in DevOps. We don't just discuss unnecessarily. We don't use them unnecessarily, right? There is a purpose. Of course, that purpose, when the tool comes, we'll see that. Don't worry about that. Got it? So that's what about introduction of DevOps today. Still, I don't know how many. Six. It won't take six, maybe just three or four. Let's say three, three, 6, 12, 14, 24, 30, 35, 50, 55, 59, 60, 63, 93, 99, 100 days exactly, excluding Sundays, or sometimes I miss the class if I have some work or something. Means 3 more months. November 4th, as I told you. So make sure you practice all these things as well. But yeah, that's forget about the time. It may be early, it may be late also. It's fine. Got it? So today we just had the introduction of DevOps. Now we'll go with flow one by one. How what happens. How we do blah 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 all these things. Starting from as I told you, why I you know why do you think I wrote tools like this in this format, in this approach, like one by one? Why I wrote something called SonarQube in the second place, or maybe in the third place, or Jira and Confluence at the last? Because they serve purpose at that level. You'll know that by from tomorrow. Because we'll start with our work start with here, then it will go here one by one. That's why I wrote line by line. That will sit. Don't worry. So for now, in today's class, any doubts so far? Any doubts? What is DevOps? So I know it will be too much. Just go through one video if it is. I'll try to upload this somewhere. But yeah, just try somewhere, watch a video if it is maybe my introduction also. I don't know whether I upload it or not in the channel, but try. If it is there, yeah, it will be useful for you. Just try, get to know what is DevOps. That's it. So then it will be easy. See, you have to know what you are doing. Otherwise, just doing it, simply by running something. Correct? But yeah. So any doubts? Any doubts so far? Anything? If nothing, yeah, we can close it. I think it's already late. Let's meet tomorrow same time. Got it? then have a nice day. Bye.